I'm going to explain about characteristics function. If you want to get my future videos, subscribe my channel. Characteristic function is denoted with phi x of t. It is also an averaging process only, like movement generating function, that is e of e power jtx. So this is also one of the averaging process. So I'll tell you here, denoted with the phi x of t, like mx of t, movement generating function, that is, if it is discrete random variable, e power tx into p of x is the average for the given random variable. If the data is varied like exponential, so then they are calculating the average by using moment generating function denoted with mgf. If it is not satisfied, in another special case any imaginary parts are there, so then they are going for, that is, characteristic function phi x of t. So that is equal, phi x of t for discrete random variable is defined as e power jtx or j phi x, both are same, multiplied with p of x. So this is an averaging process for special case. So, and also this is also named as highest averaging process for discrete random variable. So if it is continuous random variable, we can write like this: e power jtx or j phi x multiplied with density function f of x dx. This is for continuous random variable. I will give the one example for characteristic function. If phi x of t is equal, find phi x of t if density function f of x is equal 1 for the limits, given limits are 0 less than x less than or equal to 1. This is the condition they are given. Density function equal to 1, then find the phi x of t. According to characteristic function, phi x of t is equal, for a continuous random variable, if limits are there we can easily identify. So it is a continuous random variable, minus infinite to plus infinite e power jtx multiplied with f of x dx. So we can write it as, the limits are given 0 to 1, e power jtx, f of x value is 1 dx, 1 into e power jtx, and e power jtx integration is e power jtx by jt of the limits are from 0 to 1. E power jt, in the place of x substitute the limits, upper limit minus lower limit, e power jt into 1 jt by jt minus e power 0 means 1 by jt. So like this we can find the average for special case, that is the characteristic function. But one more is there, from the characteristic function phi x of t we need to find density function. In the exams you may ask, in university exams, that is equal phi x of t equal e power jtx multiplied with phi x of t dx, So here if you want f of x dx, this is f of x dx. So from this we can find f of x value. F of x is equal, density function f of x is equal, throughout 360 minus infinite to plus infinite take e power jtx this side, e power minus jtx, e power minus jtx multiplied with same position phi x of t, phi x of t with respect to omega. So this is an density function. This is an density function. From the characteristic function we can find that is density function. So it is all finally it is also an averaging process for special case. From that we can find the density function also. Thank you. If you have any doubts or suggestions or any topics required, send to me.